Well, I'm Loeffl from DLR. Before I start, I would like to apologize that most of the figures and most of the robots I will show today are seen yet, so they were presented in other presentations. But I would like to talk about design methodology, about the design process itself, and as the title says, I would like to throw it a bit over, turn it over. And yeah, how does it work actually? Though usually we build or buy a robot that's well made upon assumptions, upon guesses, and pretty nicely built a robot. Hey. Yeah, we put some controller on it. We program a don't read it. A motion planning, and in the end we put the system to our application. And in many cases, we're not really happy with the result. And well, that's no surprise, because having a robot on the desk, the controls and the planning has literally no design space left. You have a robot there, the robot has this dynamics, and your controller maybe can reshape it a bit, but you can just utilize what's there. Same for the planning, though. There are motors in, there's a kinematics, and everything defines what your optimal motion is, though you just can find it and try to utilize. Though there are many dependencies between the components of the software and the hardware itself. And yeah, the community asked always for this co-design now, and yes, it does make sense. And we would like to propose some kind of decomposition of these parts and reordering them for somewhat having these dependencies dissolved. You can't read these points, but there are more than 3, as we had before, though. I just separated the controls and mechatronics design a bit. And yeah, here the first step is know your task. So you always need to start with the task before. That's your measurement. Hey. That's where you have to scale all your ideas, all the solutions on. So if you don't know what you want to do, you can't judge is the solution good or not. And the next step, I propose to have simplified models and simplified dynamics, reduced order model, whatever, something you can imagine to solve the task. And that's important to have it early, as that's the common understanding for the controls and for the software guys and the mechatronics. That's the goal, the common goal to get on. Then, before we can start controlling, we need some rigid body model. So now we dive into the mechanics and have them kinematics, have the mass distribution. On the picture you see teaser some of our new designs. But that's a common thing, or that's the base a controller needs to be working. And yeah, when the controller, here we saw the picture of Johannes, the controller. As soon as we have a rigid body model, we can start make it move. because the model itself doesn't do anything without a controller. Though the controller can do, can make the system move, can make the system do the task, and that's the input for the control for the mechanics again to know what loads do we have in the system. And those loads can be somehow generated by passive elements. That's that step. So think about coupling, think about elasticity, think about whatever, and then make a system, do them design, solve this mechanics you defined before, really in hardware. And in the last step, as we never get what we intended, we need again a controller that will control our system, that will control the model error, the disturbances, and so on, to get a system that's working. That's my last slide. Thanks for your intake.
How have you conquered in the past the chicken and egg problem? So we always want to make sims of the things we want to do, but then people decide what they want to do after they have the hardware that works.
Yeah, that's why we try here to pose ideas before you for example, to have a kinematics, to have some system, some idea of a system to control a simulation before we build it. And what I didn't say here, of course, you can do as many iteration loops, as many optimizations, although across these phases, or putting some together to approach your solution in the end. Yeah.
On the model matching part, you mentioned you need some control to make it move and get your loads. Do you think the control there has to be sophisticated, or you can do like get an optimal solution some way and just play without feedback?
The better the controller matches that what you want to do in the end, the better your result will be. So yes, of course you can put them in a controller to have them guess and go further. But if you know what controller you want to use, of course you should use that controller. As it's different for the requirements of the actuation. It makes it different.
Do you think you'll be able to do this in PLR?
We're doing that. Okay. Yeah.